Good morning all. Welcome to today's class on functional analysis. Today we discuss a theorem. The theorem is this: let x and y be normed spaces and f from x to y be linear map, then the following conditions are equivalent. 1. F is bounded on U0 R closure for some r greater than 0. 2. F is continuous at 0. 3. F is continuous on x. 4. F is uniformly continuous on x. And 5. Norm of f of x less than or equal to alpha times norm x for all x in x and some alpha greater than 0. And sixth condition, the zero space of f is closed in x and the linear map f tilde from x over 0 space of f to y defined by f tilde of x plus 0 space of f is equal to f of x for all x in x is continuous. So we prove 1 implies 5 first, then 5 implies 4, 4 implies 3, 3 implies 2 and 2 implies 1. So that will prove the equivalence between 1 and 5. Then we prove the equivalence between 3 and 6. Proof: 1 implies 5. So the assumption is 1, that is f from x to y is a linear map and f is bounded on U0 R closure for some r greater than 0. Let's assume 1, that is f be bounded on U0 R closure for some r greater than 0. That is, f is bounded on 0 R closure means norm of f of x is less than or equal to beta for some x in U0 R closure. That is, norm of f of x is less than or equal to beta for all x in U0 R closure for some r greater than 0. If x equal to 0, then f of x is equal to 0. Therefore, 5 holds in this case, since norm f of x is norm 0, that is equal to alpha times norm 0, that is equal to alpha times norm x, alpha greater than 0. Therefore, if x is not equal to 0, then r into x divided by norm x exists, and we have norm of rx by norm x. This is equal to r. Therefore, rx by norm x belongs to U0 R closure. We have norm of f of x. This is equal to norm of f of rx divided by norm x into norm x by r. So that norm x and r will cancel to get f of x. So since f is linear, this is equal to norm of norm x divided by r into f of rx by norm x, and this is equal to norm x by r into norm of f of rx by norm x is less than or equal to norm x divided by r into beta, since rx by norm x belongs to U0 R closure. We have norm of f of rx by norm x is less than beta, less than or equal to beta. That is, norm of f of x less than or equal to beta by r into norm x. Let beta by r is equal to alpha. Since beta greater than 0 and r greater than 0, alpha is greater than 0. Therefore, norm of f of x less than or equal to alpha times norm x for all x in x and some alpha greater than 0. Now we prove 5 implies 4. So we prove. So let norm f of x less than or equal to alpha times norm x for all x in x and some alpha greater than 0. Then norm of f of x minus f of y, this is equal to norm of f of x minus y, since f is linear. This is less than or equal to alpha times norm x minus y by 5. So let norm of x minus y is less than delta. Choose delta to be epsilon by alpha. Then, since delta greater than 0, alpha greater than 0, we have epsilon equal to delta alpha. This is greater than 0. Therefore, norm of f of x minus f of y, that is less than or equal to alpha times norm x minus y, and this is less than alpha times delta, since norm of x minus y is less than delta, and you know alpha into delta is equal to epsilon. That is norm of f of x minus f of y is less than epsilon whenever norm of x minus y is less than delta. This implies f is uniformly continuous on x. So 4 implies 3 holds, since a very uniformly continuous function is continuous. Now we prove 3 implies 2. For 3 implies 2, since f is continuous on x, it is continuous at each point of x. That is, f is continuous at 0. We have 2 implies 1, since f is continuous at 0, f is bounded in some neighborhood of 0, that is, there exists r greater than 0 such that f is bounded on u0r closure. Thus we have proved 1 if and only if 5. Now we prove 3 if and only if 6. Now we prove 3 implies 6. Let f be continuous on X. We prove the zero space of f is closed and the linear map f tilde is continuous. The zero space of f, is a set of f, is f inverse singleton 0. Since singleton 0 is closed and f is continuous, f inverse of singleton 0 is closed. That is, set of f is closed. Hence, X over set of f is a normed space in quotient norm. Is a normed space in quotient norm. Therefore, f tilde from X over 0 space of f to y defined by f tilde of x plus z of f. This is equal to f of x for all x in x is well defined. Therefore, by 5 we have, so since f is continuous, we have 5. 5 is norm of f of x less than or equal to alpha times norm x for all x in x and some alpha greater than 0. Therefore, by 5, since f is continuous, there exists some alpha greater than 0 such that norm of f of x less than or equal to alpha times norm x for all x in x. Now let x belongs to x and z belongs to 0 space of f. Then norm of f tilde of x plus 0 space of f, that is equal to norm of f tilde of x plus z plus 0 space of f. This is because z belongs to the 0 space of f. This is equal to norm of f of x plus z by the definition of f tilde. And x plus z belongs to x, and by this definition it is f of x, f tilde of x plus z plus 0 space of f is equal to f of x plus z. So it is equal to norm of f of x plus z. So this is less than or equal to alpha times norm of x plus z by this 5, which is true for every z in 0 space of f. Therefore, norm of f tilde of x plus 0 space of f less than or equal to alpha times infimum of set of all norm x plus z such that z belongs to 0 space of f. So this is actually equal to the quotient norm. So this is equal to alpha times quotient norm of x plus 0 space of f. That is, we have f tilde, norm of f tilde of x plus 0 space of f is less than or equal to alpha times quotient norm of x plus 0 space of f. That is, f tilde of x plus 0 space of f less than or equal to alpha times quotient norm of x plus 0 space of f. So this implies f tilde from the quotient space x over z of f to y is continuous. Now we prove 6 implies 3. So assume that 0 space of f is closed and f tilde is continuous. Now f tilde is continuous means for some alpha greater than 0 we have definition of f of x is f tilde of x plus 0 space of f. We have norm of f of x, that is equal to norm of f tilde of x plus z of f. This is less than or equal to alpha times norm x quotient norm x plus z of f, since f tilde is continuous. So that is less than alpha times norm x, that is less than or equal to alpha times norm x for all x in x. Therefore f is continuous by 5. So we have 6 if and only if 3. We proved 1 if and only if 5. All the statements are equivalent. That's all for the day. Have a nice day.